Do you know that you're an academic champion? Do you know that you are never a dullard? So anybody that brings that up to you, oh, that you're dull, you cannot cope in this, you cannot cope with this, science is not for you, this is this, you can prove that person wrong. And that is why I, the simplifier, believe that no student is an academic dullard. You have it inside you. It's inherent, it's there inside you. All you need is something that what? Spark up that fire. And that fire is what I bring. And that is why I encourage you, share this video, like, follow as much as possible. Let it get to as many students as possible. Remember, keep telling yourself, you are an academic champion. You are not a dullard. You're not a weakling. You're not a science weakling. You're a science genius. Just keep following and you will see that genius come out from within. Organic chemistry. Remember that this is based on somebody asking us to teach alkane, alkene, and alkyne. And I told you that before you can understand alkane, alkene, and an alkyne, you must have a basic understanding of what organic chemistry is. Yeah. And last time I told you, in my last video I told you, organic chemistry is simply the chemistry of what? Carbon compounds. Carbon. Now that means it is pertinent for us to understand carbon as an element. What is so special about carbon? What is that about carbon that you and I must know if we must understand organic chemistry? Follow me and let's get to it. Look at carbon having an atomic number of 6. Electronic configuration 1s2, 2s2, and 2p2. I believe you still remember this. I sure hope you still do. Now, this is the electronic configuration of carbon. Now, that means if I'm going to draw the orbital diagram for carbon, this is 1s2, this is 2s2, this is 2px, my 2py, and my 2pz. Remember that the p orbital is split into 3 orbitals of equal energy, px, py, and pz. And remember that these 3, I said they have equal energy. That means they are what? Degenerate. So whenever you come across this word degenerate, it means it has the same what? Energy level. I hope you got that. If I place my s orbital in a magnetic field, it will not split. If I put my p orbital in a magnetic field, it will split into 3 folds. And that is px, py, and pz. Now, I said these 3 orbitals, these 3 splitting orbitals have equal energy level. And that is why we call them what? Degenerates. When you put your d orbital into a magnetic field, it will split into 5 folds. And what are they? It will split into dxy, dxz, dyz, dz squared, and dx squared to what? Y squared. 5 of them. dxy, dxz, dyz, dz squared, and dx squared to y squared. And please take note again, these 5 orbitals are of equal energy level. That means they are what? You got that right. Degenerate. If I place my f orbital in the magnetic field, it will split into 7 folds. But remember, it will be what? Complex. Okay, this is for another day. This is for another day. Alright, now, our carbon, atomic number 6, electronic configuration, 1s2, 2s2, and 2p2. Now, if I'm going to introduce these 6 electrons into this is 2, 2, but when you fill your p orbital, remember, based on Hund's rule, electrons are filled singly before you pair them, based on Hund's rule. Hund's rule, you see, we have a lot to discuss. We have 3 major rules that guides our filling of orbital. Aside the Hund's rule, we have the Aufbau's principle, and we have the Pauli's exclusion principle. Okay, the Hund's rule is the one that tells us that when you fill degenerate orbital, you must do that singly. Fill them 1-1 before you double. Aufbau is the one that tells us that when you fill orbitals, you fill from lower energy level before you fill higher energy level. While Pauli's exclusion principle states that when filling orbitals, 4 Out of them, remember we have the N, the L, the MS, and the ML. Is it not? Principal, is it not? Azimuthal. Spin, you will still remember that. Azimuthal. Magnetic, you still remember that. Now, Pauli is telling us that if three of these orbitals are the same, the spin must always be different. That is Pauli. But like I said, that will be for another video. Just keep following us. There will be a time where we discuss all of this rule. But today, what we're looking at is still organic chemistry. Alright, so if I want to obey Hund's rule and I want to fill the remaining two orbitals, I will not fill two here. I will just fill one and fill one. This is my orbital filling for what? Carbon. Now, if you look at this orbital diagram, it is not out of place for us to say that the valency of carbon is 2 because there are 2 unpaired electrons here. Isn't that true? I hope we're together. It is not out of place to say the valency of carbon based on this. Remember, the number of unpaired orbitals. There are 2 of them. So it's not bad to say the valency of carbon is 2. But the valency of carbon is not 2. It's always 4. So where did the 4 come about? How do we come about 4 and not 2? That is what we call hybridization. This is actually what makes carbon have an oxidation state or the valency of 4 as opposed to 2. What is hybridization? Remember, hybridization is the mixing of orbitals at their excited states. Mixing of orbitals at their excited states. Here, this is called the ground state. Carbon is not reacting with anything. But when you talk about excited state, that is when carbon starts reacting with other elements. So it is hybridization that will confer on carbon the valency of 4 instead of what? 2. And that is what we need to discuss today. Because I see some textbooks will tell you that what is the hybridization of alkane? They say sp3. What is the hybridization of alkene? They say sp2. And what is the hybridization of alkyne? They said sp. But how they came about sp3, sp2, sp, students still don't understand. And that is what I want to teach you this morning. I want to show you how they came about sp3, sp2, and what? And sp. Now look at this. Look at alkane, for example. The first member of alkane is methane, CH4. Carbon bonded with 4 hydrogen atoms. So this is what will happen. This is my ground state. When carbon is not reacting, remember? Now, when carbon starts reacting with 4 hydrogen atoms, what will happen? Let's see. That is the excited state. So let's draw the excited state now. Let's draw the excited state for carbon. This is 2px, 2py, and 2pz. This is 2s2. Now, something will happen. Before there is a hydrogen atom, 4 hydrogen atom reacting with this, there will be a promotion. Remember, this orbital is empty. So it's unfair. You can't leave this and you want to start reacting. Everybody must have something. So the closest orbital to transfer is the 2s2. So one electron will be transferred from the 2s2 orbital to the empty orbital. So now we have this, This is that electron that was promoted. I hope you got that. So every orbital now at least has what? An electron. Now, I want to fill hydrogen, 4 of them. So what will happen? These 4 hydrogen will start bonding with each of the unpaired electrons. So 1 hydrogen will come here, 1 hydrogen will come here, 1 hydrogen will come here, and the 4th one will come here. Remember, this is the excited state when carbon starts reacting now with what? Hydrogen. Now, please, I ask you, my wonderful listeners, my intelligent students, I ask you this question. Please, in this excited state formation, how many orbitals are involved? Yes, you got that right. 4, right? This, and this. This was not involved in that. Only this s orbital and 3 orbitals. So how many? I have 1 s orbital and how many p orbitals? 3 p orbitals involved in the hybridization. And that is why they said the hybridization of alkane is what? sp3. Can I hear a round of applause for me? You got that. So that is how they came about sp3 for what? Alkanes. I hope you got that. Now, if we do the same thing for alkene, the first member of alkane there is what? 18. C2H4. If you carry this out, you will see that what? You have an s orbital and 2p orbitals involved. So the hybridization of 18 is sp2. I hope you got that. The same thing will happen to alkyne. Your alkynes. For example, ethyne, that is what? C what? What's my ethyne? C2H what? H what? Remember I see NH2N minus 2. C2H what? 2. Beautiful. I hope we are with me. Alright. Now in ethyne, the hybridization for alkynes is what? Sp. That means the hybridization will be formed between just an S and a P orbital. I hope you got that. So please take note. Remember, let me just remind you, CnH2n minus 2. How I came about this, n is 2. So 2 times 2, 4 minus 2, 2. That's why this is what? The formula for ethyne. So please take note. The hybridization for alkane is sp3, I've shown you. The hybridization for alkene is sp2. And the hybridization for alkyne is what? Sp. Now, also take notes. Take note of this. They might give you this. Instead of writing, they might just give you, this is the formula for methane. This is the formula for an ethene. I have H, I have H, H, H. There will be no H here because for every carbon there are 4 bonds. So this is 1, 2, 3, 4. This carbon is filled up. If you put another one here, that means this carbon is excess. You can't have 5 bonds on a carbon. 1, 2, 3, 4. So this is methane, the first member. This is ethene, the first member. And this is ethyne. Can you see that thing? 3, 4. Complete. 3, 4. This is my ethyne. Another thing they might ask you aside hybridization is the kind of bond. Because upon hybridization, it's either you have a pi bond or you have a sigma bond. Take note. In your straight chain, all you have is a sigma bond. In a carbon double bond carbon, wherever you see a double bond, you have 1 pi bond and 1 sigma bond. Wherever you see a triple bond, you have a pi bond above, a pi bond below, and the middle is what? A sigma bond. So that means for ethyne, I have 2 pi bonds and 1 sigma bond. For ethene, I have 1 pi bond and 1 sigma bond. For methane, I just have a sigma bond. In case they ask you for the type of bonds present in each of these, remember I said I want to touch every aspect of organic chemistry. I want you to see that organic chemistry is very, very easy. It's just that it's been difficult because you have not met the simplifier. Now we are together. I want you to be that academic champion. And we'll get to a point where we start naming organic chemistry. But remember, organic compound broadly divided into 2. Every organic compound broadly divided into 2. Remember, organic compounds, organic chemistry, we have broadly divided into 2. Isn't that true? Of course, this is under hydrocarbons. Hydrocarbons. So, I can also say hydrocarbons are divided into 2. What are they? I have aliphatic and I have what? Aromatic hydrocarbons. Hydrocarbons. So, let's start streamlining it now to hydrocarbons. Compounds made up of just carbon and hydrogen alone. So, I have these hydrocarbons. I hope you understand. The aliphatic is divided into alkane, alkene, alkyne, and what? Alicyclics. Why the aromatic hydrocarbon are majorly benzene and benzene type compounds. I trust you got that. Remember, keep following us. In our next video, what we're going to do is, well, now because I have laid a foundation to organic chemistry to hydrocarbons, so we'll now start picking them one after the other to do justice to them. Join me, and keep joining me as we break down these organic compounds, as we look at these organic compounds, and in the end, you will smile because you will also be a teacher of teachers. See you in the next video.